All right, let's take a look at 22. It reads, the amount of fuel F in billions of gallons used by trucks from 1990 through 2009 can be approximated by the function f of t equals 20.5 plus 0.035 t squared, where t equals 0 represents 1990. Question for part A. Describe the transformation of the common function f of t equals t squared. Then sketch the graph over the interval. Okay, so what we're doing is basically going from this common function, this parent function, f of t equals t squared, into this transformed function here, f of t equals 0.035 t squared plus 20.5. Alright, so to determine what the transformations are on this original function that yields this, we're going to start by taking a look at the vertex form for the equation of quadratics. Okay, so the vertex form is f of x equals a times x minus h squared plus k. So our a, h, and k values can help us determine what the transformations are. Now let's go ahead and write this transformed function f of t in vertex form. So it's going to be 0.035 t minus 0 squared. There's no number being subtracted from the variable being squared, plus 20.5. Okay, so what does this tell us? It tells us that a is 0.035. This tells us about the reflection and dilation in the vertical direction. And we have h is equal to 0. That tells us the horizontal translation. And then k is 20.5. Okay, so what are the transformations here? Starting from this to that, the transformations are as follows. The graph of f of t equals t squared is compressed vertically. There's a compression because the absolute value of a is between 0 and 1, okay? It's compressed vertically by a factor of 0.035, the value of a, and shifted vertically upwards by how many units? By 20.5 units, because we have plus 20.5 as our k value. Now we're also asked to sketch the graph. You can do this by hand or using a calculator. All you just have to remember is that the vertex is hk, which is 0, 20.5. So our vertex is going to be on the y-axis because our h value is 0, so we can just call this 20.5. And what are we graphing here? We're graphing a parabola that's shifted 20.5 units upwards and opens in the upward direction since a is positive. Okay, so from 0 to, let's say this is 19 somewhere here, you're going to have half of a parabola, okay, because we know that parabolas are symmetric about their vertex. Okay, so the y-axis is basically the same thing as the axis of symmetry. So the graph is going to go something like this, just curve it up. But let me draw that again. So it's kind of like a parabola going upwards like that. Okay, now if you want to figure out the exact value of this, you just plug in 19 into your quadratic function, and then that will tell you what the output is going to be. Alright, for the b part, we have to find and interpret the meaning of f of 19 over minus f of 0 divided by 19 minus 0. Okay, so we're going to be using our calculators for this. We know that f of t is 0.035 t squared plus 20.5. Now if we compute f of 19, what does that mean? It means we're simply going to plug in 19 for t in our function. Okay, that's 20.5. And then for f of 0, we'll do the same thing. We'll plug in 0 for t in our quadratic function. This one is easy to compute by hand. This is simply 0 plus 20.5, which is equal to 20.5. Now, let's bring out our calculators. So we have 0.035 times 19 square plus 20.5. And our answer is 33.135. Okay, so that's what f of 19 is. So with these results, we can now compute what f of 19 minus f of 0 over 19 minus 0 is, which is f of 19 is 33.135 minus f of 0, which is 20.5, divided by 19. Now, if we plug that into our calculators, let's see what we get as our final result. So we have 33.135 minus 20.5 divided by 19, and that gives us a final result of 0.665. Okay, so answer is 0.665. Now, we're told to state what the meaning, interpret the meaning of the answer that we just got. So in order for us to explain what this is, I would like us to recollect a formula that is just like this, okay? So what I'd like you to recall is that the average rate of change, you can call it AROC, the average rate of change of a function, let's say f of x, on an interval AB, is given by f of b minus f of a. You can also think about it as y2 minus y1 divided by b minus a, x2 minus x1. This is the same formula as the slope formula, okay? So this is the average rate of change of a function on an interval a to b. So if you take a look at this scenario we have here, this is also an average rate of change situation. Okay, so let's go ahead and write down the meaning of our answer. Our answer basically means that the average rate of change of the function, what does the function represent? The function represents the amount of fuel that's consumed, okay? So we can write the average rate of change of the amount of fuel consumed. Remember, it's in billions, okay? In billions, from 0 to 19. Remember what 0 represents, right? 0 represents 1990. So we're going from 1990 so counting from 1990, we're going to end up, you add 19 to that, so from 1990 to 2009 is 0.665 billion gallons of fuel. Okay, so that's the meaning of the result that we just got. Now let's take a look at the C part. It says rewrite the function so that t equals 0 represents 2000. Explain how you got your answer. Now we know that initially t equals 0. Let's write that down. Initially t equals 0 represented what was it? 1990. Okay. So now we want t equals 0 to represent 2000. So this represents a shift in our axis, okay? Our axis, so let's say we have some quadratic function that looks like this, okay? Our starting axis before was on, for t equals 0 was 1990, okay? So for t equals 0, it was 1990. Now we're making a change. We want t equals 0 to be 2000. So we are actually shifting our y-axis to the right by how much? By 10 years, okay? So take a look at this visualization for a second. If you shift your y-axis to the left, to the right, what's happening with the graph? If you shift your y-axis to the right, it appears as though your graph is getting shifted to the left, okay? So you can do one of two things. Either shift your y-axis to the left to the right by 10 units, or shift the function to the left by 10 units. Okay? So we know that we can capture the transformation by actually altering the function itself. Okay? So what we're going to be doing is adding 10 to the t value. Alright? So the initial function f of t is 0.035 t squared plus 20.5. Okay, so now the new function, let's call that g of t, is going to be f composed with t plus 10. Okay, this shifts the graph to the left by 10 units, which results in the y-axis being shifted to the right to its new starting value. Okay, so that's going to be 0.035 times t plus 10 squared plus 20.5. Okay, so that's the new function that will cause t equals 0 to be to represent 2000, the year 2000, as opposed to 1990 for the original function f of t. Now let's explain our answer. So explanation. In order for t equals 0 to represent the new value of 2000, the graph of f of t, since that's what we can move, must be shifted 10 units to where? 10 units to the left. Okay, that causes, is as though we're shifting our y-axis to the right when we're shifting the graph 10 units to the left. Okay? Alright, let's take a look at the D part. It says, use the model from part C to predict the amount of fuel used by trucks in 2015. Does your answer seem reasonable? Explain. So the function from the C part, g of t, is equal to 0.035 t plus 10 square plus 20.5. Now, G evaluated that for 2015. Remember, t equals 0 represents 2000. Okay? So what does 2015 represent? 2015 is equivalent to adding 15 to the years. So we have 2015 is what we're looking for. So what we did is we added 15 to get the final year. So what are we going to do here? If t equals 0 is 2000, the time that represents 2015 is just 15 more than t equals 0. So it's going to be t equals 15. Okay, so we're going to be evaluating the function g at 15. So that's going to be 0.035 times 15 plus 10 raised to the second power plus 20.5. And our final answer, if you input that into your calculator, is 42.375. Okay? Now, does the answer seem reasonable? The answer is yes. The answer is reasonable because the amount of fuel used should be increasing, right? Because if you think about a quadratic function that we just sketched, it should show an upward trend. It should be increasing. Okay? So it's the answer is reasonable, 42.37 billion gallons. That's what it is. Okay? It's reasonable because the fuel consumption should be doing what? It should be increasing. Okay? Should be increasing with time, not decreasing. So that's what we have here. Alright, let's take a look at question 23. It says, use the graph provided to choose the best description of what the graph represents. Okay? So we have a graph here. Let's go ahead and see what the graph is telling us. This involves dropping a ball. Okay? So this point right here is a start. As you can see, t is equal to 0. Okay, so at the start, we have the coordinates 0, 40. So the 0 represents the starting time, which is 0 seconds. What does this 40 here represent? The 40 represents the initial height. This is the height that the ball was dropped from. Okay, so initially it was around 40. If you look at, we have 42s here, so we can use that to help us out. So it was around 42 feet from the ground initially at the start. And then when you get over here, this is the end of the ball drop activity. The coordinates of this point are 1.5 and 0. Okay, so what does this coordinate mean? The 0 basically represents the height from the ground. Basically, the ball hits the ground. The ball hits the ground. Okay, if you're on the ground, how far are you from the ground? You are 0 feet from the ground, right? So that's why you have a 0 here. And 1.5 basically represents the time that the ball hits the ground. So let's take a look at these options to see which one is correct. It says a ball dropped from 42 feet lands on the ground after 3 seconds. That's a problem. It landed after 1.5. B, a ball is dropped from a height of 42 feet and lands on the ground after 1.5 seconds. That is perfect. Our answer is option letter B. Alright, question 24. The table lists all the real roots of a fifth degree polynomial, p of x, and the multiplicity of each root. So x equals negative 3 has a multiplicity of 1. So we're just going to have 1 x equals negative 3. Okay? So the multiplicity is basically how many times that particular root shows up in the solution of the roots for a polynomial equation. Negative 1 has a multiplicity of 1, so this one shows up only once. Positive 1 has a multiplicity of 2, so that means it's going to show up twice. How do we capture that? We're going to write x equals 1 and another x equals 1. Okay, reflecting that multiplicity of 2. Okay, shows up twice. Multiplicity of 2. And then the last root is x equals 2 with a multiplicity of 1, so it shows up once. Now, in order to write this in factored form, we'll set every term equal to 0. So you add 3 to both sides here. X plus 3 equals 0. This one you add 1 to both sides. They'll set it equal to 0. This you subtract 1 from both sides. You do that again. And then this one you subtract 2 from both sides. We use the reverse of the zero product property, multiply all the expressions on the left. We'll have the leading coefficient a times x plus 3 times x plus 1. X minus 1 shows up twice, so we can use properties of exponents to express this as x minus 1 square. And then we have x minus 2 equals 0. Okay? So the general factorization, if you take a look at the options here, the correct answer is option letter C. Alright, let's take a look at question 25. It says a fourth degree polynomial with real coefficients is found to have exactly 2 distinct real roots. What must be true about the other 2 roots? Okay, so one thing you want to note, actually 2 things that you want to note. First fact is that imaginary roots occur in pairs. Okay, they are normally conjugates of one another. And then also, according to the FTA, the fundamental theorem of algebra, FTA, a polynomial of n degree has n complex roots. Okay, has n complex roots. And the complex roots that a polynomial of nth degree has could be a combination, or is a combination of real and imaginary roots. Okay, sometimes you might have either all real, all imaginary, or a combination. It doesn't really matter. Okay, so let's take a look at this scenario here. The degree of the polynomial is equal to 4. Okay, so if the degree is equal to 4, that tells us that the number of complex roots according to the FTA is equal to the same thing as the degree, 4. So out of these 4 complex roots, they could be a combination of real or imaginary, or one of both, either one or the other. The problem tells us that 2 of them are real. Okay, so if the number of complex roots that are real, number of real complex roots if they are 2, then what must the other 2 be if the number of real and imaginary should add up to give you complex? It automatically follows that the number of imaginary complex roots is going to be the difference. Okay? The roots that are not real are the ones that are imaginary. So what do we do with 4 and 2? You simply take 4, the complex roots, which represent all the roots, and you subtract the ones that are real, and you're left with 2, the number of imaginary roots. So the answer to question 25, let's see, one real root, 1 is real. No, that doesn't make sense because 2 are real. Both roots must be real. It says there are exactly 2 real roots, so the other 2 can't be these 2 because that will make it 4. Okay, so option B is wrong. Option C, both roots are imaginary roots that are complex conjugates. Perfect. It tells us that they're both imaginary and they are complex conjugates because imaginary roots occur in pairs. All right. All right, let's take a look at question 26. It says, consider the graph of p of x below. Which general factorization correctly represents p of x? So this is very similar to the problem we did in 24. Let's go ahead and find out what the roots are. Okay, so you want to note the following. The x-intercepts of a polynomial function is the same thing as the roots. Okay, so we have 1, 2, 3 x-intercepts, which means we have 3 roots. Okay, this is -3 right here. So our roots are the x-intercepts, x equals -3, x equals +2, and x equals 4. Okay? Now, to express it in factored form, we're going to set each root to 0. So we have x plus 3 here, add 3 to both sides. X minus 2 here equals 0, subtract 2 from both sides. And x minus 4 equals 0 as a result of subtracting 4 from both sides. Now, using the reverse of the zero product property, we're going to have a times x plus 3 times x minus 2 times x minus 4 equals 0. Alrighty? So we can clearly see that our answer is option letter A. Alright, let's take a look at 27. It says the graph of p of x is shown below. Which general factorization correctly represents p of x? So this is similar to question 26. The only difference here is that the value of a is specified in the options. So we are going to need to make use of the leading coefficient test and end behavior in determining what the correct answer is in addition to the roots. Okay, so remember we talked about roots being equal to your x-intercepts. So we have 1, 2, 3, 3 x-intercepts here, and these 3 x-intercepts represent your 3 roots. Okay, so your roots are x equals -3, x equals 2, and x equals 4. Now in factored form, we'll simply set every single equation equal to 0. So we add 3 to both sides here, x plus 3 equals 0. Subtract 2 from both sides here, x minus 2 equals 0. And then subtract 4 from both sides here, x minus 4 equals 0. Now, going back, the reverse of the zero product property, we're going to have a times x plus 3 times x minus 2 times x minus 4 equals 0. Okay, so let's see if this result can help us eliminate some of the options that are present here. Let's see, x plus 3, well, this is wrong. It doesn't match what we have because this should be x plus 3. Moving along, x minus 3, this is no good. So x plus 3, x minus 2, x minus 4. Okay, that looks good. Now let's take a look at option D, x plus 3, x minus. Okay, so we don't even have to use the zero product property here. X plus 3, x minus 2, x minus 4 is the correct answer. Option letter C. Okay, for number 28, it says use the graph of p of x to answer the questions. Okay, so the A part, it says true or false. The leading term of p of x when written in standard form is positive. So we're going to use the leading coefficient test here. Okay, so according to the leading coefficient test, according to the leading coefficient test, if a polynomial rises to the left and right, what can we conclude about the sign of A and the symmetry of the degree of the polynomial? If it rises to the left and the right, we automatically know that A is going to be positive and the degree will be even. Okay, so if it rises to the left and to the right, the leading coefficient A, the leading coefficient will be positive, and the degree of the polynomial will be what? The degree of the polynomial will be even. Okay, so if it's even, it either rises or falls both to the left and right. If it's odd, they do different things. Okay, either it falls to the left and rises to the right, or it rises to the left and falls to the right. Okay, so true or false? The leading term of p of x was positive. Absolutely, this is true according to the leading coefficient test. Okay, it's going to have a positive leading term. So it rises to the left and rises to the right, just like a happy face. Okay, now let's take a look at the B part. From the graph, p of negative 3 is equal to 0. The multiplicity of the factor x plus 3 is even. Is this true or false? You have an even multiplicity, namely 2, when the graph touches the x-axis. Okay? It just touches it and goes back. So for example, here you have an even multiplicity for x equals 4 because it doesn't cross, it just touches like a touch and go. Okay? But for negative 3 right here, does it just touch or does it cross? For negative 3, it crosses. So the multiplicity is 1, which is an odd number, which makes option B false. Alright, so let's answer the question first. The answer is false. We're asked to explain why. Well, the graph of p of x crosses, okay? It crosses the x-axis at x equals negative 3. So the related factor x plus 3, so the multiplicity of that factor, the multiplicity of the related factor is what? How many times does it show up? It shows up exactly once, okay? So the multiplicity of the related factor x plus 3 is 1. What kind of number is 1? Odd or even? Is 1 which is odd. 1 is an odd number, okay? So anytime a function cuts the x-axis, the multiplicity there is always 1, which is odd. But if you have a touch and go situation like here, the symmetry is going to be even, okay? Which is 2. Alright, let's take a look at 29. It says if f of x is 2x to the fourth plus 7x to the third plus 3x squared minus 8x minus 4, find the possible rational roots of f of x. Okay, so let's write down the formula again. Formula for positive possible rational roots. So possible rational roots are given by positive and negative factors of p divided by positive and negative factors of q. Okay, so you have to be careful in your selection of p and q for any polynomial that you're given. Alrighty, so let's go ahead and write down the polynomial again, and then specify what p and q are. Okay, so p is always the constant. Alrighty, it goes backwards. This is our p-value here. And q is always the leading coefficient. So our leading coefficient here is q, which is equal to 2. So our possible rational roots, according to the formula, are going to be the positive and negative factors of p, which is 4, of negative 4, sorry, divided by the positive and negative factors of 2. Okay? So, what are the factors of negative 4, the positive and negative factors? We have 1, plus or minus 1, plus or minus 2, and also plus or minus 4. We're now going to divide that by the positive and negative factors of 2. Factors of 2 are plus or minus 1 and plus or minus 2. Now, let's write down our possible rational roots. What you do here is you take one factor from the top and you divide it by all the factors in the denominator. And then you move on to the next one on the top, and then you go like that, okay? So let's start with plus or minus 1. Plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 1 divided by plus or minus 2 is plus or minus 1 half. Plus or minus 2 divided by plus or minus 1 is plus or minus 2. Plus or minus 2 divided by plus or minus 2, 2 over 2 is 1. We already have plus or minus 1 here, so we do not need to repeat it. Plus or minus 4 divided by plus or minus 1 is plus or minus 4. Plus or minus 4 divided by plus or minus 2 is plus or minus 2, but we already have it here, so no need for repetition. Final answer is plus or minus 1, plus or minus 1 half, plus or minus 2, and plus or minus 4. Correct answer is option letter D. Alright, let's take a look at question 30. It says, given the polynomial q of x and q of 4 equals 6, which statement is correct? Alright, real quick reminder concerning roots or factors of a polynomial, okay? Alright, reminder number 1. If r is a root of some polynomial f of x, guess what? Then the function evaluated at that root is going to give you 0. Okay? Reminder 2. If r is a root of f of x as indicated here, then what? Then its related factor x minus r is going to be a factor of f of x. Okay? So those are the two things we want to keep in mind. Now for q of x, we know that q of 4 equals 6. So our r value here is equal to 4. Okay? So since q of 4 is not equal to 0, what does that mean? Then 4 is not a root. Okay, if it were a root, we'll get a 0. And its related factor, so we have x equals 4, and we set it equal to 0, x minus 4 equals 0. Its related factor, x minus 4, is not a factor of q. Also, okay, they go together. It's not a factor of q of x. So let's take a look at the options here and see which one harmonizes with one of the conclusions that we were able to draw from this situation. X equals 4 is not a root. That's perfect. X equals 4 is not a root. If it were a root, guess what? Q of 4 will be 0. Okay? So our answer to question 30 is option letter A. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming semester 1 exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, just place your questions in the comment section below, and we'll be more than glad to support you. We update videos to our YouTube page on a consistent basis, so do subscribe to our channel so you can get updates on our new uploads. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.